Hi class, let's take a look at problem 8. Now in problem 8, they're given us a position function, and the first part of the actual problem is for us to provide a sketch. Now for this particular problem, the amplitude is actually 1/8. So in terms of the cosine function, I'm just going to label it as this being technically 1/8, and then the value at the bottom technically negative 1/8. Also, this is going to be the values of t, and technically on this one, this would be the values of s. In terms of the coordinate points that we're providing, our domain, it's not including the value of 0, but it's going all the way to 2 pi. So let me just say that this is going to be the values of 2 pi, then this would be pi, this pi over 2, and then technically 3 pi over 2. Now, our function happens to be the cosine function, so it's gonna not be defined at 0. So I'm just gonna put an open circle in this direction and then just put the arrow or the dotted arrow that the function technically could still continue, but it's not being defined in terms of how in terms of the domain here. So we still have that this is the 1/8. Okay, and then the next portion is going to be the other coordinate points that we do have. At pi over 2, we technically happen to be at 0. At pi, we're at negative 1/8. Then it goes back to 0. And then it is going to be technically defined at 2 pi. Also, let me put the arrow, and then let me attempt to complete the actual sketch. So our function is going to be doing this, and this is technically the function s of t, which happens to be the position function of 1/8, technically cosine of t. Now, all they want on the first part is a basic sketch. And for this one, it's not defined at 0 because t is greater than 0. And after that, we have a continuous function. And then the last portion that we're putting is at 2 pi. That's actually it for the sketch of it. The other parts of the actual function, they're going to ask us to evaluate the velocity and the acceleration function. So let me just write out what the position function was. In our position, it's at s of t, and this is equal to the 1/8 cosine of t. Now, they want velocity. By definition, when we talk about the velocity, that represents the first derivative of position. So in this case, let me rewrite it as velocity. In this case, our function v of t, it's equal to s prime of t, which is just going to be the 1/8 cosine of t, and we're going to be evaluating the derivative. So s prime of t, it's going to be equal to, well, the derivative of cosine actually contains a negative. So cosine, its derivative is going to be negative sine. And then don't forget the constant. So in this case, I'm just going to rewrite it as negative 1/8 in cosine of t. That's going to be our first answer for part B. The other portion that it's asking is for the acceleration. And in this case, they're defining it as the second derivative. Your function a of t happens to be the second derivative of the position. So let me just rewrite it as a of t, it's equal to technically s double prime of t, which happens to be the negative 1/8. Oh, I'm so sorry. This is supposed to be sine. And then we end up with 1/8 cosine of t. Okay, so our a's of t, this is equal to negative 1/8 cosine of t. Okay, let me check it because I did have an error. As we are evaluating the derivative of cosine is negative sine. So this should be negative sine of t. Then the derivative of sine, it's just a regular cosine, but you have to carry the negative. So we still have that negative carried over. That's actually it for this answer. Another aspect of it that could be asking for some of the problems is actually the domain. So technically your position is only defined from the values of 0 less than the values of t less than or equal to 2 pi. In this case, I'm just going back to the domain that was given, and then that's going to be the same for all the other ones. So technically, comma, 0 less than t less than or equal to 2 pi, and then also 0 less than t and less than or equal to 2 pi. That's actually it for this problem. All they want us to do is to technically look at a position function and then based on that provide the definitions. Also, I just wanted to mention that some of the problems on the textbook, they may be evaluating the absolute value. So that is a possibility. In this case, I'm just following exactly what the definition is for those.